If I were to think of all of the possible rational roots of this polynomial, I would have to be thinking about P over Q. P is always the constant. Q is always the leading coefficient. So if I'm going to take all the factors of P and divide it by all of the factors of Q, I'm going to say, okay, what numbers can I multiply together to get 12? 1 times 12 will get me 12. 2 times 6 will get me 12. 3 times 4 would get me 12. And I'm putting the plus or minus because if you notice, it's a negative 12. Since it's a negative 12, I could have positive 1 times negative 12, and I could have negative 1 times positive 12 to give me negative 12. So the plus or minus gives me all combinations possible. I'm always going to have plus or minuses when I'm trying to find all of the possible rational roots. All of the factors of Q, so all of the factors of 2, I can only multiply 1 and 2 together. So those are all of the factors of Q. So now that I've found all the factors of P and I've divided them by all the factors of Q, I'm going to separate them into rational numbers. So basically whole numbers and fractions. I'm going to take every P and I'm going to divide it by every Q. So my first P is plus or minus 1. I'm going to divide it by plus or minus 1. Then I'm going to take that same plus or minus 1 and divide it by plus or minus 2. Now that I've taken 1 and divided it by 1 and 2, which were in the denominator, I'm going to move on to my next numerator, which is 12, and I'm going to divide that by everything in the denominator. So I've taken plus or minus 12 and divided it by plus or minus 1 and plus or minus 2, because those are the numbers in my denominator. I'm going to go on to the next numerator, which is 2, divided by everything in the denominator. I'm going to go on to my next one, divided by everything in my denominator. My next one in the numerator, and I'm going to divide it by everything in the denominator. And finally, my last number in the numerator will be divided by everything in my denominator. I've found all of my possible rational roots. So the last thing I need to do is just simplify anything that I can. So if I'm looking here, I have plus or minus 1 over plus or minus 1. That is simply plus or minus 1. 1 divided by 1 is 1. This right here, 1 divided by 2 is 1/2. 12 divided by 1 is 12. 12 divided by 2 is 6. 2 divided by 1 is 2. 2 divided by 2 is 1. 6 divided by 1 is 6. 6 divided by 2 is 3. 3 divided by 1 is 3. 3 divided by 2 is 1/2, but I'm just going to leave it as 3/2. 4 divided by 1 is 4. And 4 divided by 2 is 2. So now that I've simplified all of the fractions that could be simplified, I'm going to write down anything that I have left. I'm noticing already that I have a couple of of plus or minus 3s. I have a couple of plus or minus 1s, a couple of plus or minus 2s. I'm not going to list the repeated numbers. So my final answer would be plus or minus 1. I like to do the whole numbers first. Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus a half, and finally plus or minus 3 halves. Of the 1, 2, 3, 4, 5, 6, of the 12 that I had when I did P over Q, they simplified to only 1, 2, 3, 4, 5, 6, 7, 8. 8 possible rational roots. So this right here would be the answer to my question. What are all of the possible rational roots of that polynomial? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 1 half, and plus or minus 3 halves. Those are all of the possibilities. Those are all of the numbers that could be x-intercepts. These are not all of the x-intercepts. Oh, I apologize. Before I said that there were 8, it's really 16 because plus or minus 1 represents two numbers, positive 1 and negative 1. Please keep that in mind.